This is a video tutorial for tutorial 5A question 3. 5A question 3 tests our ability to differentiate trig functions. The first one we need to differentiate is sine of cosine of x. So there's a few things that we need to know for this differentiation. The first is I need to know the chain rule. So the chain rule says that if I want to differentiate a big function, f of g of x, so a composition of two functions, first I differentiate the outside, leaving the inside constant, and then I multiply that by the derivative of the inside. Another way of writing this that you may have seen is dy by dx is equal to dy by du times du by dx. So you differentiate the outside with respect to the inside multiplied by the derivative of the inside with respect to x. This is the first thing we need to know. The second thing that we need to know is how to differentiate sine, and that is it becomes cosine. And we also need to know how to differentiate cosine, and that is it becomes negative sine. So with all of this information, I'm ready to differentiate this one. How do I do it? So differentiate the outside. Differentiate sine, I get cosine. So I get cosine of x, holding the inside constant. Multiply by the derivative of the inside. This is negative sine of x. So my final answer, just let me tidy it up a bit, is negative sine of x cosine of x. Please note that this is not cosine squared, nor is it cosine squared of x. That would be something else. This is cosine composed cosine of x. We write this cosine of x. If we look at 3b, what do we have? 3b asks us to differentiate 2 plus 7 cosine x over 3 plus 5 cosine x. How do I do it? Well, what I need to use this time, I need to use the quotient rule. If you remember, the quotient rule says if I differentiate with respect to x two functions, u over v, both of which are functions of x, I firstly differentiate u, keep v constant, then minus away, keep u constant, differentiate v, whole thing over the denominator squared. So this is our quotient rule. We're going to use that here. So what do I get? Alright, the first thing I'm going to do, divided by the bottom line, 3 plus 5 cosine x squared. What do I get first? Well, differentiate 2 plus 7 cosine x. 2 differentiates to be 0. 7 cosine x becomes negative 7 sine of x. And we keep the denominator, constant. Minus, differentiate the denominator. So differentiate 3 plus 5 cosine x, I'm going to get negative 5 sine x times 2 plus 7 cosine x. So let me expand that a little bit. I'm going to get what? So let me again leave the bottom line the same. 3 plus 5 cosine x whole thing squared. Then I get minus 21 sine x minus 35 sine x cosine x plus 10 sine x plus 35 sine x cosine x. Minus 35 sine x cosine x plus 35 sine x cosine x minus 21 sine x plus 10 sine x. That's going to give us negative 11 sine x over 3 plus 5 cosine x whole thing squared. Alright, how do I do part C? Part C, I need to differentiate x sine x cosine x. Well, the problem with this, we know how to apply the chain rule, the product rule, right? So again, if I have to differentiate u times v, what do I get? Hold u constant, differentiate v, plus differentiate u, hold v constant. So it looks something like this. How do I apply it here though? Well, I'm just going to have to apply it like this. Okay, so I'm going to apply it first okay, so let's see how this happens. Firstly, let's differentiate the x. I get 1. Hold the other one constant. I get sine x cosine x. Plus, hold the x constant and then differentiate sine x cosine x. Now to differentiate this one, again I need to apply the product rule. So I'm going to get sine x cosine x here. The 1 is just multiplied by 1, so it does nothing. Plus x, apply the sine rule. So differentiate sine, hold cosine constant, I'm going to get cosine squared x, plus, hold the sine constant, differentiate the cosine, I get minus sine x. So this is sine x cosine x plus x cosine squared x minus sine squared x. So there's a lot of simplification I can do here. I hope that you can see that. So how can I simplify this? Sine x cosine x, this is the same thing as a half sine 2x using the trig formula. Hold on, hopefully it loads. Using the trig formula, sine 2a is 2 sine a cosine a. And this one as well, we're going to use the cosine equivalent, that cosine 2a is equal to cosine squared a minus sine squared a. So this is plus x cosine 2x. And so I can simplify that if I like, but this is actually fine enough already. One thing I do want to point out is that I could have also done my simplification right up here, that this is the same thing as differentiating x sine 2x whole thing over 2. So applying my sine 2a is 2 sine a cosine a to this expression inside the brackets here. However, I also want you guys to see what happens, how do you do a product rule with more than 1 times sine. So this is how you do it. You just have this ddx, the second part. So put some brackets in. Okay, last one. Last one I'm going to do for this question, I'm going to differentiate cosine squared x degrees plus tangent x degrees. Now, if you recall, our differentiation only works when x is measured in radians. So the first thing I'm going to do, or the first thing I'm going to have to do, is I'm going to have to convert this all into radians. So this is cosine squared x pi upon 180 plus tangent x pi upon 180. Right, now what's the second problem? Well, second problem is I don't actually know how to integrate a few of these things. For instance, I don't actually know how to integrate cosine squared, nor do I know how to integrate tangent. Sorry, well that's fine though, because I'm going to differentiate them anyway. Okay, sorry, brain was somewhere else for a bit there. So let's differentiate. Differentiating cosine squared, remember this is the same thing as cosine x pi upon 180 whole thing squared. So the 2 comes down the front. Keep the inside constant. Decrease the power by 1. Then multiply by the derivative of the inside. So differentiating cosine, I'm going to get minus sine pi x over 180. Differentiate, multiply by the derivative of the inside, pi over 180. So that's the first one. Then if I differentiate tangent, I get secant squared and then differentiate the inside, I'm going to get pi over 180. So what does that give me? Well, I can convert back to degrees now that I've done my differentiation, so all these angles just become x degrees. So this is, let me see what I can factorize out the front. I can factorize out pi over 180. 2 minus 2 cosine x degrees sine x degrees plus secant squared x degrees. And that simplifies, using our formula here, that simplifies to pi over 180 secant squared x degrees minus sine 2x degrees. And that's it for question 3.